All right, so we are here with our stat students ready to go over a question where we actually have to solve for the sample size. So I told the girls this on Friday, those that were here, that one of the interesting things about learning this material is that the first thing you do, one of the first things you do before you actually go run a survey or a poll is to find out how many people you want to go talk to. Okay? So that is finding the sample size. So it's one of the first things that you will do if you end up becoming a pollster at some point in your life, if that interests you. Like you know me, trying to get that job with the census, but still haven't heard anything back yet. It's okay. Stay positive. All right, here we go. We have the EPA, and they have an investigator who wants to know the proportion of fish that are inedible because of chemical pollution downstream for an offending factory. If the answer must be within a margin of error, so margin of error of 3%, at the 95% confidence level. Charlize? How many fish should be in the sample? Okay? So, let's just go ahead and write down the formula that you're going to get for tomorrow's quiz. You're going to get this formula, I'll write it above it. P hat plus or minus Z star times the standard error of P hat. And you're also going to get the formula, standard error of P hat equals the square root of P hat times Q hat over N. Okay. So I told the girls on Friday that in this formula, the Z star times the standard error of P hat is called the margin of error. Okay, so margin of error. So this was something that I mentioned yesterday, that you're going to get this formula, but I'm not going to say in the formula, hey, by the way, this is the margin of error. All right, so you need to know that every confidence interval is some sample statistic, or this is a proportion from a sample, plus or minus the margin of error. Okay, so that formula right there is the margin of error. So I'm going to use that. So in the problem for number 2, I'm going to write ME, which stands for margin of error, is equal to Z star times the standard error of P hat. Okay, so I want to make sure your brain understands how to do that because it's going to be happening tomorrow. It's not easy stuff, right? So if you just expect to roll in and get a good grade, you won't. All right, so put in the time. You got to prepare. Okay, so we know the margin of error. What margin of error is the EPA looking for here? Very good, 3%. And you always want to write it as a decimal, 0.03. We also know, thanks to Charlize, that if we have a 95% confidence level, our Z star is going to be 1.96. Okay? And we're going to multiply by the standard error of P hat, which is over N in there. Now, this problem, different from what we did on Friday, the girls that were here, is not giving us a sample proportion. Right? Do you see how that is it? There's no other data values or statistics or anything, any numbers that's going to help us here. All right? So what you do, if you're doing a problem like this, and they don't give you a sample proportion to put in here and then obviously subtract from 1, you're going to use 0.5. Because if you use 0.5 for P hat and then consequently 0.5 for Q hat, it gives you the biggest sample associated with that margin of error. Okay, so that's something that it's rarely needed because a lot of times the problem will give you P hat. But if you don't get it, plug in 0.5 for P hat, and then obviously you know if we use 0.5 for P hat, we have to use 0.5 for Q hat. So that's one of those like little things that could be the difference between, bless you getting the question right or not.
So you put 0.5.
When you don't know P hat, you use 0.5. Because this guarantees the smallest number in the numerator, which guarantees the largest, and it's weird, the largest sample size. All right? Exactly. Because remember, it's always this one minus from subtracted from 1. Right? These always have to add to 1. And I'll tell you this, guys, if it had said in the problem, p hat is 0.46, and you went ahead and used 0.5 and 0.5, I'd still give you credit. All right, give you full credit. All right. So if you just want to tell yourself, I'm always going to use 0.5, go for it. I'll give you full credit. Absolutely. No stay. Right. But it's telling you if you always want to use 0.5, because your sample size will always be bigger than someone who didn't use the 0.5. All right, so it's just more time and more money on you to get more people or more fish. Okay. Yeah, like you guys are going to do number 4 here. All right. It doesn't give you one, so you have to use 0.5. Let me show you the one we did. When did we do that?
So even if it gives you one, you can still just...
Absolutely. Remember when we did this one on Friday, girls?
Yeah.
Girls that were here and boys that watched the video, right?
Yes, sir.
We did this problem. And we used from number 4 a p hat of 0.73. Okay, so we used that there. But if we had used 0.5 and 0.5, totally fine. It would have been a bigger number, right? But it would have been right. Okay? Remember, I'm grading it, so I'll know the possible answers. I'll do the answer key for both. Okay, so let's finish this. And this is where it gets a little slow, all right, because the rest of this is just algebra. You'll notice we're solving for n, and n is buried. It's buried in a fraction, and it's buried in a radical. All right, it is buried. So we have to do a lot of algebra, okay? I'm going to go slow. I'm going to show all my work. I just want you to know that when I get here on my key, I just go n equals the answer, because everything is button pushing. All right, but I'm going to show you the work if you want to follow along. Take out your yellow calculator if you have it. All right, so I'm going to not multiply. I'm going to divide both sides by 1.96. Doing that is going to move this z star to the other side. Okay? Are you good, so? All right, you good? You them boys? Ah, nice. I feel like I've heard a group called that. Okay. 0.015306122. Okay, equals the square root of 0.5 times 0.5 over n. Now again, I'm writing a lot of numbers here, but this is just like, I'm honest with you, it's a waste of my time, right? I can do algebra, but I'm just showing you all the work, how to do the algebra. But I don't expect to see this work on the quiz. Like, if you know how to push all the buttons, please don't show me the work. I want to see this, right? I want to see that before I did the red, and then write the answer. Do all the work in your calculator. Okay? So now, how do I get rid of this square root? Square it. So I'm going to square both sides. So square that number. Okay, so if I square that number, then write down point. I know I'm writing the number, but just know, like, I'm not rounding any of this yet until the very end. You don't want to round any of it. I know the calculator has to round it. Okay? Everybody still with me? Okay, so now I told the girls on Friday that you can think of this if you want. You can put the number on your left side of the equal sign over 1 and then do cross products, so proportion. Cross products are equal to each other. Or you can just move in your brain the n over by multiplying. So multiply both sides by n. That's going to move it over to get 0.000234277 times n equals 0.5 times 0.5. So the last step is to divide both sides by that number in front of n. And if you do that in the calculator, you should get your answer. So n equals,
1,000.
yep, 1,067.1 fish. Okay? Now, whenever you do this, all of this work, right? Whenever you do all of this work, no matter what your decimal says, right? This decimal says 0.1. So if I was rounding according to rules that you learn in elementary school, I would round to 1,067. But if you went and sampled 1,067 fish, you would actually not get a margin of error of 3%. You would get a margin of error of 3.0000001%. Right? Just be barely above 3%. So whenever you're doing this, you want to think always round up. Always round up. So how many fish are you going to tell this EPA investigator to go get to test, to sample to test? 1,068 fish. All right? And after we do show you the Z-stars, I'll just tell you my story about how I know to always round up, okay? It's something I learned in college. Always round up. Everybody good? Yes? Feel good? Feel confident? Not yet. I have to do another thing. And then after I hit stop on the recording, this is not really appropriate for this, right? No one needs to hear this story. All my viewers. All right, they're here for the content, right? The math. Okay. I don't like to laugh so hard once it's, like just a slight chuckle. But just makes me feel sad. Okay. Let's first go to this link. You should have this link. All right, everyone should have this link. All right, if you have your Chromebook, go to this link. This was from the email I sent on January 9th. January 9th. Okay? So I went ahead and told you guys to memorize 1.96 for 95% and 1.645 for 90%. Very good. So let me just use this blank page here. So 95% and 90%. We good, guys? All right. You can, if you want to find a place to write this down, you can. Otherwise, just watch. Okay. So because we're using the normal model to approximate all of this stuff we're doing, right? You remember that statement from yesterday? All right. You're going to need that statement tomorrow. All right. According to, you're going to write, the conditions have been satisfied, so I'm going to use the normal model to run a one proportion Z interval. Memorize that statement. So I'm going to draw two normal models. Okay, and when you draw this for a 95% confidence level, for a confidence interval, this is 0.95. And when you draw it for 90, in the middle is 0.9. Okay, so on Friday, I had the girls work with me on how much is in each tail for this 95% confidence interval. 2.5%, right? There's 5% left. So if you split that in two, you get 0.025 there and 0.025 over here. Okay, so if you wanted to find the Z-stars that are associated with this 95% level of confidence, you're going to go into your calculator and you can actually use one of the functions. All right, so if you want to find the Z-star on the left, you're going to type in the area to the left of that. How much of the curve is to the left of that Z-star? 0.025. So you're going to go to your link, and you see where it says this inverse CDF here, 0.5186. We're going to type in 0.025. And what do you notice pops up? Negative 1.96. Okay? Now, what about if I wanted to find the positive Z-star? How much is to the left of that one? Do you see the 0.95? Do you see the 0.025 when you add this together? You're right, Catherine. It's 0.975. So if you type that in, you'll get the positive 1.96. But it doesn't matter because you're using plus or minus in these formulas, right? You're saying plus or minus the z star. So we can do the same thing with 90% confidence. Okay? If you look at the one on the right, 90% confidence, how much is in each tail? How much is in each tail? 5%, 0.05. All right, because you have 10% split in two. So if you want to find the negative z star here, you'd plug in 0.05. So 0.05. You'll see 1.645. If you wanted to find the positive z star, you're going to type in everything to the left of that, which is 0.95. 1.645. The reason this is confusing, okay, just be honest with you. The reason this gets confusing is if you wanted to find this positive one, okay, this positive z star, what did we actually type in? What did we type in to find this positive z star for 90% confidence? We typed in 0.95. And so that gets kids messed up because you typed in 0.95 to find the z star for a 90% confidence level. You see how that can get confusing? Okay? So let's say it was supposed to be, instead of these two, which you should memorize, right? Let's do one more, that it's 98% confidence. I've seen that one before on the AP test. Okay? So if it's 98% confidence, how much is in each tail?
1.
There's 1% in each tail, 0.01. Because there's 2% left, all right? And if you split it into two spots, you get 1%, okay? So for the z star on the left, I'm going to type in 0.01. And get 2.326. 2.326. And if you wanted to find the positive version, you would type in everything to the left here. So 0.98 plus 0.01 is 0.99. You would type in 0.99. And it should be no surprise that that is the same number but positive. 2.326. Okay? It's going to take time, right? This isn't something that you're like, oh, I saw you do it once, I got it, right? So we'll practice this, all right, especially when we get to our review in many weeks, 3 weeks. We'll practice this, okay? Are there any questions about this here? Any questions about how to find your z stars? Again, memorize these two. They're the most common. I'm sorry? Do you need me to write them down again? This one is 1.645. This one is 1.96. Memorize those z stars. Z star. Called critical values. Okay, let's go ahead and show you the other link. So the other link, what do you want? I don't care. Yes, Math Cracker. This one here. All right, and I want to show you, remember that problem that we did yesterday with the, let's see if I remember this, the unemployed men that were married? Remember that problem we did yesterday about all the unemployed men, and we looked at what proportion of them are married? All right, I'll pull that up here. I want to show you how you can use Math Cracker to confirm your answer or find your answer. So this is the problem that we did yesterday, right here. Okay? So in this problem, all right, let's look at Math Cracker. It says, how many favorable cases? So this is number of successes. So how many unemployed men that were married were there? You guys remember? It was the 1356 number? Yes? All right. Do you want, here, why don't I go to my mechanics? All right, do you see my mechanics in blue, the 1356 for X? So I'm going to type that in. So type in 1356. I'm pretty sure it doesn't work if you put commas, so don't put commas. And just keep closing the ads. And don't click the ads. I don't know what it'll do. So, okay, sample size. How many, that's not what I wanted. How many unemployed men were there? Thank you. 3,499. Let's type that in. Okay. Now, on this third dialog box, it says you can provide instead of X if you know the sample proportion. We calculated it, so if you wanted to type it in, you could, but because you typed in a number for X, it's going to divide those two anyway and get it for you. So you can leave this blank. I just leave this blank. All right. What level of confidence did we use? 90%, right? 90%. So I'm going to type in, I always like to do decimals, so 0.9. Okay. And when you're ready, don't click, I know they really try to get you here, don't click start. You do not need a PDF converter, or maybe you do. Do it on your own time. And then hit calculate. Let's see if this works. I could be wrong. Maybe they want you to use commas. Okay, buffering, loading. Yes. Oh, really? Oh. It's called ad blocker?
Yeah, ad blocker.
All right, I'll look into it. Thank you. Okay, so do you see how they calculated p hat for you, the 0.388? And then if you look near the bottom, it actually gives you the confidence interval, 0.374, 0.401. There's a lot of good information here. You can read it. I would say if you're going to use this tomorrow, which I encourage you to use this tomorrow if you'd like, every year I say this, but every year I get students that do this. There's a statement at the bottom right above start over where it says, based on the data, the 90% confidence interval for the population proportion is right? And then it says that we're 90% confident. So it gives you the statement, but there's no context. So if you just write, I am 90% confident that the true proportion, population proportion is contained by this interval, I'm not going to give you full credit because you need to mention that it's about the proportion of all unemployed men who are married. Okay, so make sure you throw the context in there or you won't get full credit. Okay, that was a lot.